Alright, welcome back. In this video, we're going to go ahead and make this into an elliptical pattern, not only for right here and right here, but also for instances like right here. We see that the boomerang doesn't really move in this elliptical pattern, but rather it moves assuming this is like on the x-axis. So what we need to do is to take into account our boomerang tower angle when we're creating this. Now, how do we do that? Well, we use math, and here's where I can look for that. So here's the parametric equation of an ellipse found at 0, 0, with the major axis parallel to the x-axis and minor axis parallel to the y-axis. Then this is how we rotate it. So this is the parametric equation for a rotated ellipse, still centered at 0, 0. Now, to shift it from 0, 0, we just add this value right here, the center x and center y. So let's go ahead and break it down and see how we can relate this into our code. So let's go ahead and look. Let's look at our code right here. We already have cx and cy. This is cx right here, my center x position. This is cy. Now here we have this sine variable angle, right? This angle. So if you already accounted for cy and cx, which one does that angle thing account for? Is it this component or is it this component? Well, neither really. We still haven't really even rotated our equation. So currently we just have this right here. The radius times the cosine of angle. We see right here. Let's see. Radius. That's the firing range, and we're just modifying by the value of 4, and times the sine of angle, cosine of angle for x, sine angle for y. We have that, and we're just offsetting it. Now let's go ahead and rotate it. So how do we do that? Well, by doing this. So we do rx, the radius of the major radius, times cosine of alpha, which ranges from 0 to 2 pi radians, times cosine of theta, which is the ellipse rotation angle, minus ry, the minor radius, times sine alpha, which is the parameter ranges 0 to 2 pi radians, times sine theta, the ellipse rotation angle, plus the center. Now, I already went ahead and coded all this, so what I'm going to do, I'm going to copy and paste this. So I'm going to copy. I'm just going to go ahead and copy the whole event. And what I'm going to do, I'm going to paste it. Now, I'm going to go ahead and click here. I'm going to toggle it off. So this no longer is accounted for in our code. I'm going to do the same thing right here. And paste. And obviously you can't copy and paste. So how can you do that? Well, you can type exactly what I have right here. And it's a lot. So good luck. This is great practice for typing, for observing. So let's go ahead and break it down again. Here's my cx. That's my center point in my x position. Then right here, what do I have? I have my firing range, which is my radius. I'm dividing by 2. Times cosine of, what is this? 2 radius, boomerang tower variable angle. Well, I haven't really made an angle yet. This needs to be my scene variable angle. In the other one, I went ahead already, but this won't quite work. So I need to use the scene variable angle for here. So for now, I'm going to replace this into a, let's see, variable. Where can I find my variable? Variables. Scene variable. This is going to be a scene variable angle. Okay. And I'm going to close that off. So right there, times Boomerang Tower dot variable angle. Oh wait, this needs to be taken off. So this right here needs to be taken away. So my cosine of my scene variable angle times the cosine of my Boomerang Tower dot angle. And again, my Boomerang Tower does have an angle. So let's go ahead and look at that equation again. Compare it side by side. Here's my center, x, right here. Then I add to it this radius. I'm only dividing by 2, which is my major axis, I'm assuming. And then I am multiplying it by cosine of angle, which is cosine of alpha. And alpha is a parameter which ranges from 0 to 2 pi radians, times cosine of my Boomerang Tower angle. So the ellipse rotation angle, the actual rotation of my ellipse, which if you look at this demo, is this value right here. Alpha right there. Then I'm subtracting from it the minor radius, and so the only thing I did is I divided by 4 instead of 2 up here, times the sine of my, well, I need to replace this Boomerang Tower variable angle because I don't have that anymore. So I'm just going to copy this right here and replace times sine of this. Awesome. And for my y position, I need to do all of that for this equation. So I'm go ahead and type this all out. I'm just going to replace this Boomerang Tower variable because I don't have it made yet in this version. So cosine 2 radians right here and right here. Wow, that was a lot. Let's do the same thing for this one. So replace Boomerang Tower variable angle with the variable angle. Replace Boomerang Tower variable angle. Alright. And now I have, you also notice this background color. The reason I have this background color is it can help me see which part of the code I'm in. Am I in this part where the x difference is greater than y difference? Or am I in this part where the x difference is less than or equal to this y difference? Now that I have it all coded, I'm going to go ahead and comment this out, toggle disabled, disable the code. Let's go ahead and try it out. Okay, so, hey look, it's turned. So we can see that it actually rotates an ellipse like this now. And we can see what part we are on, if the x difference is greater or if the y difference is greater. And that, folks, is why we need math, so we can make great video games. Awesome, so we finally got the rotational part of the ellipse ready. Now, we don't want to rely on a scene angle, right? Because each tower should have their own, I guess, angle. So we want to make that into, what do we call it? An object variable right here. So let's go ahead and give this angle. And it doesn't really matter what initial value, we can give it no initial value. And what we're going to do is we're going to switch all of that with the right here, this object variable. So remember what we changed? Well, we're going to change it all back. So I'm going to go ahead and replace variable angle, which is the scene variable, with my object variable. So object variable, object variable, Boomerang tower, angle. There we go. And I'm going to copy and paste that wherever I see variable angle. Here, here. Alright, do the same thing for down here. And let's try it. Save and go. So it's not working. Why is that? Well, if you remember, what we're doing is we're changing our scene variable angle. We need to change our object variable. So we're just going to make it our object variable add 360 times time delta. The object is Boomerang. Variable is angle. I'm going to add to it 360 times time delta. Right? And let's go ahead and try it out. Awesome, it works. Make sure you save. So you might be asking, what's the difference between this code and this code? Again, it depends on the major axis and the minor axis. And if we look here, it only affects two parts of each equation. So if we look up here, where the x is the major axis, what we did is we divided it only by 2, rx. And we divided the ry, the minor axis, if we look here, right here, rx. So divided by 2. This one, the y is the, we use the major axis, so we're only dividing it by 2. And y, we're dividing it by 4. But then this one, if y is the major axis, we're going to divide the y. Oh, that's not quite right. Let's see. Ry is the minor axis. Maybe we should modify this. Does it look correct? Okay. Okay. It looks fine. Maybe we might not need to modify it. So let's see. Rx is the major radius. So the major radius, if x is bigger, x should be it. So for that one, we use this one divided by 2. Well, actually, it doesn't matter, right? If we think about our equation, we're still always using the firing range. And we're basing off of our firing range. Right? So the radius is just going to be, for this one, it's just going to be divided by 2 if x is bigger. And y, well, right here, it's going to be our minor radius, so we're going to divide by 4. Then we use the same values, x and y. So we divide the x one by 2, because x is our major radius, and y by 4. Okay. Now what if y is our major axis? Well, then we should, y is our major axis, correct? So then rx now becomes ry. Right? Think about it. Rx doesn't mean the x, it's always x. It just stands for the major radius. If y difference is bigger than our x difference, then y is our major axis. So Rx, we just replaced with the word y-axis. So we still want to divide by 2, and we still want to divide our minor one by 4 to make it smaller. And same thing. So all checks out. If you have any questions about this, or want a better explanation, or more in-depth explanation, feel free to ask in class. But we're at a good place, and we have changed everything to angle, and we just have a few more touches in order to make it appear and disappear.